In the grand cosmic theatre of the universe, where galaxies collide, stars birth and fade, and black holes warp the very fabric of space-time, there exists a realm so perplexing, so inscrutable, that it promises to rewrite the very tenets of our understanding. One might ask, where does this realm, known as quantum mechanics, fit into this vast tapestry? How has it, from its mysterious corners, beckoned us to question the very nature of existence? From the sunlit dance of atoms in the heart of stars to the frenzied, flickering dance of particles on the quantum scale, the universe has always told a story. Its laws inscribed in the symphony of celestial bodies and the tiniest of subatomic particles alike. But just as a melodious tune can be disrupted by an unexpected chord, so too did the discovery of quantum mechanics introduce a discordant note into the harmonious tune of classical physics. But was this a note of chaos, or a deeper harmony waiting to be understood? In the late 19th and early 20th centuries, the scientific community stood on the shoulders of giants like Isaac Newton, whose laws of motion and gravitation had illuminated the mechanistic workings of the cosmos. These laws, concrete and unyielding, offered a sense of order, a promise that the universe in all its grandeur could be explained, predicted, and understood. Yet, as scientists peered closer into the heart of matter, anomalies began to surface, chinks in the armor of classical understanding. Particles behaved in ways that defied reason, existing in states of probability rather than certainty. Could it be that the universe, at its most fundamental level, operated not on the deterministic principles of classical physics, but on the probabilistic whims of quantum mechanics? The great minds of that era, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger, each grappled with this paradigm shift. They unveiled a world where particles could exist in multiple states at once, where observing a particle altered its state, and where particles, though separated by vast distances, could mysteriously influence one another. This was the dawn of quantum mechanics, a revelation so profound that it sent shockwaves through academia, challenging and reshaping our very conception of reality. Indeed, the implications were so staggering that even Albert Einstein famously declared, "God does not play dice with the universe." Yet the dice had been cast. As experiments confirmed the bewildering predictions of quantum theory, a new era of understanding beckoned, one filled with tantalizing questions. How does the quantum realm influence the macroscopic world we inhabit? Are the two realms distinct, or do they intertwine in ways we are yet to fathom? What secrets lie in the dance of particles, and what existential riddles do they whisper? Let us venture forth, dear viewer, into the mire of quantum dimensionality, where the known contours of space and time meld and twist. Seeking answers, we embrace the beauty of the veiled unknown, for it is said that in mystery lies the essence of discovery. As we navigate this dance of quanta and relativity, perhaps we'll find ourselves redefining not just the universe, but our very role amidst its grand illusions. In the annals of history, there exist those pivotal moments when humanity's understanding of the cosmos takes an unexpected turn. Picture, if you will, an idyllic English garden in the 17th century. A tree, an apple, and a contemplative observer named Isaac Newton. The apple's descent gave birth to classical mechanics, a realm where planets followed precise paths and apples reliably fell to the ground. Here's where myth and history entwine. A popular narrative suggests that an apple, after striking the pensive Isaac Newton, birthed the ideas of classical mechanics. While this account is evocative, a more likely scenario is that Newton observed apples falling from trees and began to contemplate the invisible forces at play. No apple-on-head moment needed. Instead, imagine a deeply reflective mind, using simple observations to unravel profound mysteries. Through this introspection, Newton pioneered the realm of classical mechanics, where planets adhere to precise orbits, and yes, apples invariably fall to the ground. This revelation, however, was just an overture to a symphony soon to be enriched by the perplexing cadences of quantum mechanics. But how did we move from the deterministic world of Newtonian physics, where cause led to effect in an understandable sequence, to the unpredictable, almost whimsical world of quanta? Was there a moment, or perhaps several, where our trust in the classical began to waver? Aboard this journey, we'll find that classical theories, in all their elegance, painted a portrait of a universe that was coherent, predictable, and mechanical. Yet, as we delved deeper, peering into the infinitesimal, we encountered behaviors that defied classical intuition. Particles behaving like waves, and waves behaving like particles. Uncertainty, not as a mere product of our ignorance, but as an inherent trait of the universe. Let's momentarily travel backward through the corridors of time. After Newton, the 19th and early 20th centuries witnessed immense advancements in classical physics. The study of thermodynamics, the behavior of heat and energy, led to our mastery of steam and the engines that powered the Industrial Revolution. James Clerk Maxwell elegantly unified electricity and magnetism into a single framework, predicting the existence of electromagnetic waves, a precursor to our modern world of radio, television, and other wireless communications. Then entered the era of Einstein. His special and general theories of relativity drastically transformed our understanding of space, time, and gravity. Stars, galaxies, and the very fabric of the universe bowed to his insights. But as vast as these discoveries were, they too had their limitations. They couldn't explain the behaviors of the incredibly tiny, the subatomic realm. Mercury's odd orbital shift, the peculiar spectra of heated elements, and the stability of atoms were questions classical physics struggled with. These discrepancies hinted that our understanding was incomplete. There were chinks in the armor, suggesting that beneath the surface of classical theories lay a deeper, more profound truth. A realm where the conventional logic of large bodies failed. A realm of quanta. Can you imagine a world where the same particle exists in multiple places at once? Or a reality where two particles, separated by vast cosmic distances, somehow know each other's state instantaneously? It was clear that our classical understanding was reaching its limit, desperately beckoning for a new paradigm. The stage was set. It was time for a quantum leap. While the revelations of quantum mechanics might feel otherworldly, they are deeply rooted in painstaking observations and experiments. As we journey further, remember this. Each quantum enigma we encounter was not born out of wild speculation, but out of the need to explain real observed phenomena These aren't just abstract theories. They are the universe whispering its secrets, challenging us to rethink everything we thought we knew. So, dear viewer, are you ready to embark on this enthralling expedition, to journey from the certainty of Newton's apple to the enigmas of the quantum realm? As we wade through this sea of wonder, let us keep an open mind, for in the words of Richard Feynman, if you think you understand quantum mechanics, you don't understand quantum mechanics. Let's see just how deep the rabbit hole goes. In the grand expanse of the universe, mysteries abound, waiting to be unraveled. But some of the most profound enigmas lie not in the vast reaches of space, but deep within the infinitesimal realm of the subatomic. Welcome, dear viewer, to the heart of quantum mechanics. But what is it about this realm that so captures our imagination and challenges our very understanding of reality? Have you ever pondered the interplay of particles so intimately connected that the fate of one instantly affects the other, regardless of the distance between them? This phenomenon, known as entanglement, is one of the marvels that quantum mechanics presents. Two particles can become so intertwined that the state of one particle can determine the state of another, even if they're galaxies apart. Imagine for a moment two synchronized dancers moving in perfect harmony, yet separated by continents. That is the magic of quantum entanglement. Information streaks across the void at speeds defying classical physics, as if space itself becomes irrelevant. Yet, as we delve deeper, we encounter another puzzling concept: the wave function collapse. Think of a symphony with countless instruments playing in harmony, producing a rich and vast sound. Suddenly, upon observation, all instruments fall silent, save for a single note. This lone note encapsulates the essence of the wave function collapse in the quantum world, a domain where mere observation has the power to define reality. Now let's take a moment to reflect. Why does this matter? Why do these abstract concepts hold significance in our lives? The answer is technology. Specifically, the budding domain of quantum computing. This is where the magic of the quantum realm is harnessed to process information in ways previously thought impossible. Unlike the binary world of classical computing, where bits are either a 0 or a 1, quantum computing operates on qubits, which can exist in a superposition of states. This allows quantum computers to perform complex calculations at speeds that would leave classical computers in the dust. Imagine unlocking cryptographic ciphers, complex codes used to secure and protect information, in seconds, tasks that would take millennia for current machines, or simulating complex biological systems to create groundbreaking medicines. The potential of quantum computing is boundless. But let's take a step back. How did we arrive here? Our journey through quantum mechanics is not just a dive into a world of probabilities and particles. It's a reflection on the interwoven nature of existence itself. As we venture further into this abstruse domain, remember that every revelation, every nuance further illuminates humanity's insatiable quest for knowledge. As we transition, I invite you to ponder this. If the universe is a grand symphony, then isn't quantum mechanics its most intricate and enigmatic composition? In the intricate dance of existence, few phenomena are as enigmatic as entanglement. Picture this: two particles, once intertwined, now separated by vast distances, yet mysteriously connected in ways that defy our everyday understanding. When one changes its state, the other reacts instantaneously, regardless of the miles that lie between. But how? How can something in New York feel the touch of its partner in Los Angeles instantaneously? Albert Einstein, the very architect of relativity, dubbed this perplexing behavior as spooky action at a distance. Indeed, it seemed to threaten the very sanctity of the speed of light, a constant Einstein held dearly in his theories. How could information, it seemed, travel faster than light itself? At its scientific core, quantum entanglement is a phenomenon where the quantum states of two or more objects, such as particles, become interconnected. This means that the state of one particle is dependent on the state of another, no matter the distance between them. In the world of quantum mechanics, a particle can exist in multiple states simultaneously, a phenomenon known as superposition. But once measured, a particle collapses to a single state. When entangled particles are involved, the act of measuring one particle's state instantaneously determines the state of its entangled partner, even if they are galaxies apart. But how does this work? To delve into the mechanics of it requires a dive into the intricate realm of quantum mechanics. It's not so much about particles sending signals faster than light. Instead, it's more about the entangled particles acting as one unified system despite the space between them. The correlation between their states exists without the need for information to be exchanged, making it seem as if the changes are occurring instantaneously. But the universe, in all its grandeur, is not here to pander to human intuition. Groundbreaking experiments throughout the 20th century, from Allen aspects to the tests at Delft, solidified the eerie reality of quantum entanglement. The field of quantum mechanics is among the most rigorously tested in science. Thousands of experiments using advanced technologies like lasers, superconductors, and particle accelerators have been conducted globally to understand this subatomic world. Laboratories from CERN in Geneva to MIT in Massachusetts have dedicated vast resources to testing and verifying quantum theories. This robust examination of quantum phenomena is not limited to entanglement alone. Quantum tunneling, superposition, and the nature of quantum fields have all undergone stringent experimental scrutiny. The consistent results from these myriad experiments, spanning cultures, methodologies, and technologies, emphasize the robustness of quantum theory. It's a testament to science's rigor. The more we probe, the more quantum mechanics holds up to the challenge, establishing it as a cornerstone of modern physics. Not just a product of theoretical equations, but a tangible, verifiable phenomenon that the scientific community had to wrestle with and eventually come to accept. These findings, profound and groundbreaking, pose an existential challenge. Does our understanding of space and time require a paradigm shift? In our classical world, we understand cause and effect, action and reaction. Yet in the quantum realm, entanglement nudges us to rethink. It urges us to delve deeper into our universe's peculiarities, asking us, what truly binds the fabric of reality? And while you ponder on this, remember that this is but one facet of the quantum world. One enigma in a landscape brimming with mysteries. As we peel back the layers, prepare to question, to wonder, and most importantly, to understand the universe's rhythm in a way we never have before. Is it not fascinating that the deeper we look, the more the universe challenges our perceptions? What other truths lie veiled in the realm of the quantum? Hold that thought as we move forward, spiraling further into this journey of the infinitely small and profoundly impactful. In a world bound by causality, where every effect has a cause, the realm of quantum mechanics audaciously defies our most cherished beliefs. If quantum entanglement tested our understanding of space, then wave function collapse confronts our very notions of probability and determinism. Imagine, if you will, a universe where an event's outcome is not just uncertain, it's fundamentally unpredictable. But what does this truly mean for us, the beholders of this grand cosmic ballet? The concept of wave function collapse is like a coin suspended in mid-air, neither heads nor tails until observed. It is at this precise moment of observation that the quantum state, which previously existed in a superposition of probabilities, collapses to a single outcome. It's as if the universe holds its breath in anticipation, only deciding the course of action upon being watched. You might wonder, could this imply that our very act of observation affects the outcome? This mind-bending contemplation was famously symbolized by physicist Erwin Schrödinger through his thought experiment featuring a paradoxical feline, Schrödinger's cat. Enclosed in a sealed box, along with a radioactive atom that has a 50% chance of decaying and triggering the release of a deadly poison, is the cat both alive and dead until observed? How can something exist in two states simultaneously? The philosophical ramifications of wave function collapse run deep, touching the core of our understanding of objective reality. Are there multiple realities branching out at every quantum decision? Or is our perception of reality merely a construct always in flux, molded by our interactions? In the musings of philosophical introspection, the age-old query arises: if a tree falls in the woods and there's nobody there to hear it, does it make a sound? Does an event truly transpire without an observer? This question, in its essence, parallels the quandaries of quantum mechanics, hinting at an even deeper, perhaps universal truth. Some posit that consciousness itself is the foundation upon which the very fabric of the universe is woven. Under this perspective, the physical world around us is not just passively perceived by consciousness, it is an emanation or projection of it. The observer in this framework is not an external entity peering into the cosmos, but an integral part of its very existence. If we adopt this stance centered around consciousness itself, wave function collapse, Schrödinger's cat, and the many perplexities of quantum mechanics might be viewed through a new lens. Could it be that the reality we navigate is not an independent structure, but a holographic projection shaped and molded by our conscious interactions? The enigma of the quantum realm then transforms from a puzzle of unpredictable particles to a deeper inquiry into the nature of consciousness and its role in manifesting the universe. In contemplating these ideas, we must acknowledge that they journey beyond the strictly empirical realm, touching upon the very essence of existence and purpose. While the interconnectedness of consciousness and physical reality remains a subject of intense debate, there's an undeniable allure in the proposition that our very being, our awareness, is not just a passive witness, but a master sculptor of the cosmos, and there are many strong clues that this is in fact the case. Our journey into the quantum domain has revealed more than just the peculiarities of subatomic particles. It has prompted us to question the nature of reality itself. As we continue to delve deeper, we must remain open to the possibility that the universe is not just a vast expanse waiting to be discovered, but a reflection, a mirror, showcasing the boundless potential and mystery of consciousness. In this ever-evolving dance between understanding and wonder, let us not merely seek answers, but also learn to appreciate the questions. For in the intricate tapestry of existence, every thread of inquiry not only unravels the universe's secrets, but also weaves us closer to the essence of our very being. These questions, born from the very heart of wave-function collapse, lead us to ponder: is reality a well-defined entity, waiting for us to unveil it layer by layer? Or is it an intricate dance of possibilities, only taking form in the presence of a conscious observer? While the quantum realm may remain an enigma, wrapped in layers of mystery, our pursuit of understanding showcases humanity's insatiable curiosity. As we inch closer to demystifying these profound interconnections between entanglement and wave-function collapse, let's pause and reflect. In a universe teeming with probabilities, what other secrets await our discovery? What new horizons of understanding might they unlock? With every revelation, we do not just understand the universe better, we come closer to understanding ourselves. In a universe brimming with enigma and wonder, few realms are as tantalizing as the fusion of quantum principles and our modern technological ambitions. What might it look like, we ask, when the age-old principles of quantum mechanics, established by pioneers like Planck, Heisenberg and Schrödinger, meet the gleaming ambitions of the 21st century digital renaissance? Welcome, dear viewers, to the awe-inspiring domain of quantum computing. Let's pause for a moment to grasp the significance of this junction. Classical computing, the one that powers your smartphones, laptops, and the colossal data centers, works on the bedrock of bits, zeros and ones. But what if there was a way to transcend this binary? What if we could leverage the strange rules of the quantum realm, where particles exist in superpositions, not just as ones or zeros, but rather both at once? Enter the quantum bit, or qubit. Unlike the classical bit, a qubit has the uncanny ability to exist in multiple states simultaneously. Imagine the exponential possibilities that arise when these qubits are entangled, intertwined in a delicate dance of interdependence, defying the classical understanding of information processing. The sheer power of qubits, when manipulated and measured, leads to possibilities that classical bits could never fathom. But why should we care? What does this mean for us, for our societies, for the future we are crafting? To begin, the transformative world of quantum computing is no longer restricted to theoretical musings. It's here, and its early triumphs are already reshaping industries. As of now, they are nascent, embryonic, hinting at a future where they might outstrip the computing power of even the most advanced classical computers. Their potential applications, limitless. Imagine decoding the intricate pathways of human genetics in a fraction of the current time, leading to groundbreaking strides in personalized medicine. Ponder over the ramifications in cryptography, where today's most secure codes could be rendered obsolete, challenging the very essence of privacy and digital security. Or perhaps conjure the potential in drug discovery, where quantum computers could simulate intricate biological processes, opening doors to treatments for ailments that have long eluded us. Yet beyond these tangible prospects emerges a compelling synergy between quantum computing and the thriving field of artificial intelligence. Particularly the integration of quantum paradigms with large language models, LLMs, the zenith of machine learning prowess, beckons a horizon of limitless potential. Could quantum-enhanced LLMs pioneer breakthroughs hitherto unimaginable, creating a symbiotic evolution between machine understanding and quantum logic? As intriguing as it sounds, the story doesn't end there. It's conceivable that as we unearth novel forms of AI, perhaps lying dormant in the shadows of our current understanding, quantum principles could play an essential role in their manifestation. Intriguingly, this relationship may soon become recursive. Envision a scenario where quantum computers, bolstered by advanced artificial intelligence, embark on designing even more powerful, efficient, and intricate quantum machines. A feedback loop where each advancement in one domain propels exponential growth in the other. Where might this symbiotic crescendo lead? To horizons that, at this juncture, might seem like the realms of science fiction. Yet, as we've learned, the line between fiction and our technological reality is a rapidly blurring one. Are we then on the cusp of a quantum revolution, one that might redefine the landscape of technology, medicine, security, and even philosophy? Might we one day look back at this fusion of quantum mechanics and technology as a pivotal epoch in human advancement? But let's not be too hasty in our predictions. With immense promise also comes profound challenges. The volatile nature of qubits, their susceptibility to external influences, and the need for super-cooled environments make the practical realization of quantum computing a Herculean task. Yet, as history has shown, human tenacity, coupled with the thirst for knowledge, has a knack for turning the seemingly impossible into the tangible. Before we venture further into the implications of our quantum exploration, let's take a brief respite to absorb what we've unraveled. The quantum realm, previously an abstract facet of our universe, is intertwining with our tangible reality, and its manifestations promise to redefine the essence of computation and innovation. What next, we wonder? What horizons lie ahead, and what mysteries await our grasp? For now, dear viewer, let's bask in the revelations, the promises, and the profound possibilities that quantum computing brings to the table. And as we transition to our next chapter, let's remember that the true essence of discovery lies not just in the knowledge we gain, but in the questions we dare to ask. So, shall we continue this quest? In our monumental expedition through the vast and mysterious expanse of quantum mechanics, we have journeyed beyond the tangible fabric of what we once understood as reality, forging ahead into an enigmatic domain. A place where traditional physics surrenders to the whims of the quantum realm, where particles flit between states of existence, seemingly governed by probability, and where the very act of observation alters the observed. Did you ever imagine that the very framework of our understanding of reality could be so deeply challenged? That particles could be intertwined across vast cosmic distances, instantly echoing each other's states? This phenomenon, known as entanglement, once perplexed the likes of Einstein. It was a dance of nature he famously labeled spooky action at a distance. Yet, as we dove deeper, we encountered the wave function collapse, an arena where the act of merely observing catapults potentialities into realities. Do you remember our foray into Schrödinger's cat? That whimsical yet profound thought experiment where a cat inside a box exists simultaneously as alive and dead until observed? It highlights the very essence of quantum unpredictability and shows how interconnected and interdependent these principles truly are. Now, imagine harnessing such baffling principles into tangible technologies. Quantum computing stands as a beacon of humanity's audacious endeavor to channel the arcane power of the quantum world, offering us computational capabilities beyond our wildest dreams. It's not merely about faster computations, but about reimagining what computational prowess could truly be. Looking back, doesn't it seem like we've traversed not just scientific concepts, but a realm of pure wonder? Have we not forged a profound pathway, skirting the very essence of existence? It's as if we've journeyed together through an otherworldly odyssey, confronting enigmas and marvels that both boggle the mind and exhilarate the spirit. For those of you who have traveled this path with us, ponder upon this. How has this journey shifted your understanding of the universe? How have these revelations reshaped your perspective on reality, technology, and even the very nature of consciousness? We hope that as we've demystified the intricacies of quantum mechanics, we've also kindled a flame of curiosity within you, a burning desire to not just understand, but to question, to speculate, and to marvel at the cosmos and its enigmatic workings. For it is up to you and you alone to know thyself. As we prepare to dive into the broader implications of these discoveries, let's carry forward the essence of our journey so far. Let's remember the marvels, the mysteries, and the transformative potentialities that the realm of quantum mechanics has unveiled to us. For in understanding the smallest particles, we edge closer to comprehending the grandest of cosmic spectacles. In a universe teeming with wonder and curiosity, few areas of science are as perplexing and provocative as quantum mechanics. But to truly grasp its transformative power, we must venture beyond mere scientific intrigue and delve into its practical and philosophical ramifications. How many of us have gazed up at the night sky, pondering our place in the cosmos? Quantum mechanics challenges us to consider that the fundamental fabric of existence might be more intricate and interconnected than we ever imagined. At the quantum level, particles behave in ways that seem to defy conventional understandings of logic, time, and space. This isn't just an abstract realm of research, it's a harbinger of tomorrow's technologies. Imagine industries reinvented, machines redefined, and technologies birthed that seem nearly magical in their capabilities. As we have discussed, the theoretical possibilities of quantum computing could reshape fields like medicine, finance, and communication, amongst many others. In a world augmented by quantum technology, the current bounds of computing could seem as primitive as a horse-drawn carriage in the age of rockets. But quantum mechanics doesn't merely offer technological marvels. It compels us to re-examine our foundational beliefs. As we venture deeper into this quantum realm, we confront not only the intricacies of subatomic particles, but the profound mysteries of existence itself. What does it mean for determinism if particles can exist in states of uncertainty until observed? Does this challenge our notions of reality itself? If you've ever contemplated the nature of consciousness, quantum mechanics offers even more tantalizing possibilities. Are our minds, in some way, entangled with the universe? Could the bizarre behaviors we observe at the quantum level have implications for our understanding of consciousness, free will, and the essence of what it means to be? Delving into the enigma of consciousness, it's imperative to note that the idea of consciousness as primary isn't just confined to age-old philosophies or spiritual traditions. Modern scientists and thinkers have begun to contemplate this very notion. Consider Michael Talbot, author of The Holographic Universe, who explored the possibility of our universe being a hologram, implying an interconnectedness that stems from a deeper, fundamental layer. Donald Hoffman, a renowned cognitive scientist, has been developing theories and mathematical models around the concept of conscious agents, suggesting consciousness as the very fabric of reality. This isn't folklore or mere speculation, it's a rigorous intellectual pursuit backed by mathematical and theoretical explorations. The interconnectedness of all existence might not merely be a poetic thought, but a profound truth grounded in science. While it's prudent to remain open to continuous discovery and understanding, it's undeniable that the boundary between what we once considered metaphysical and what is scientifically tangible is becoming ever more porous. And so, as we stand at the crossroads of comprehension, we must recognize that quantum mechanics isn't just about decoding the universe's secrets. It's about understanding our place in it and pondering questions that have haunted humanity's psyche since the dawn of contemplation. What is reality? Are our lives predetermined? Is the universe truly as it appears, or is there a deeper, more mysterious order to it all? For every answer quantum mechanics offers, a myriad of questions arise, pulling us deeper into its mesmerizing embrace. The implications are vast, the takeaways profound, and the journey nothing short of mind-bending. Our expedition into the quantum realm has offered a glimpse into a world where the lines between science, philosophy, and the very nature of existence blur. As we've unveiled the staggering potentialities of quantum technologies and pondered the existential conundrums it poses, remember, this is just the beginning. With every revelation, the universe beckons us to explore further, question deeper, and marvel at its enigmas. We invite you, our esteemed viewer, to accompany us on this never-ending odyssey, to challenge your perceptions and open your mind to the myriad possibilities that quantum mechanics presents. After all, in a quantum universe, isn't anything possible? As the tapestry of quantum mechanics unfurls before us, one cannot help but feel a sense of awe and wonder. It's as if we've embarked on a voyage through the very fabric of reality, making discoveries that both baffle and enthrall. Our journey thus far has revealed enigmas and marvels, each more perplexing than the last. But like any intrepid explorer will tell you, the true essence of discovery lies not in what we've already unveiled, but in the tantalizing mysteries that beckon from just beyond our reach. Have you ever paused to ponder what quantum revelations await us on the horizon? In this grand theatre of subatomic wonders, what enigmatic performances are yet to play out? Quantum mechanics, as intricate as it is, continually intertwines with other realms of science, blurring the lines between what we once thought separate and distinct. This intricate dance hints at a deeper understanding, one that holds promise for revelations that might once again revolutionize our comprehension of the cosmos. Arcspanner invites you, dear viewer, to be more than a mere spectator. Become an active participant in this grand narrative. As we stand at this pivotal juncture, peering into the vast expanse of quantum possibilities, it's essential to remember that every revelation, every insight has been made possible by the insatiable curiosity of minds like yours. Are you ready to plunge deeper into the quantum realm, to explore realms where even photons fear to tread? To wrestle with questions that might very well redefine our understanding of reality itself? With Arcspanner as your guide, step forth into the shadows of mystery. Become a beacon of intellect, illuminating the dark corners of ignorance, and boldly journey where few have ventured before. Let us keep this fire of curiosity alive, for it is the very essence of progress. The universe beckons, and Arcspanner is here to guide you through its labyrinth. So, as we conclude our session today, we extend an earnest invitation. Journey further, delve deeper, and let us together weave the next chapter in this grand symposium of discovery. Will you join us? This presentation is brought to you in part by Astro Genitus. This segment is an advertisement sponsored by the creator of these wonderful and imaginative books. Astro Genitus is not merely a coloring book, it is a vessel for voyages unimaginable, a compendium of 6 distinct realms of imagery waiting to be brought to life. Each volume in the Astro Genitus series unfolds a universe within, boasting 198 intricate images and their grayscale counterparts. A twin galaxy of creativity for the artist to explore. With every book offering a unique cosmic journey, the collection spans an endless array of worlds, each meticulously segmented into categories that promise a vast coloring odyssey. Begin with Astro Genitus, Resonantia Cosmi, Volume 1, where serenity meets the stroke of the artist and the wonder of pigment unravels. Each book in the series is a crafted constellation of chromatic splendor. As you traverse through the 6 categories, You will discover amazing celestial wonders and their grayscale echoes, beckoning with the silent whisper of potential. The pages, envisioned by Kaya Spectrus, act as a bridge to the profound, portals to places where time weaves into the eternal, where the strokes of your hand are the architects of universes. These are not mere pages, they are portals to tranquility, to realms where the ancient dances with the futuristic in peaceful symmetry. Printed on premium paper that cradles each hue and cherishes every gradient, your work transcends the act of coloring. It becomes a legacy, each shade a note in a visual symphony that will resonate beyond the stars. Let the Astro Genitus series be your guide through the enigmatic imagery beyond time and space. Here, within the vastness of these 495-page books, your creativity is the vessel and your imagination the compass. Celebrate the timeless act of coloring with Astro Genitus, where each stroke on the page is a step in an immortal journey. With a myriad of books to choose from, your story in hues is limitless, a constellation of dreams waiting to be charted. Astro Genitus is more than a collection. It is a homage to the dreamers, the creators, the colorists who seek the profound quietude within the cosmos of their mind's canvas. Embellish your collection with the tapestry of dreams and the very fabric of stars. Cherish these treasures as you share them with friends and family, for each page is a reflection of your unique artistic spirit. Embark on your artistic voyage with Astro Genitus today. Color the universe in the unique palette of your soul. Order now through Amazon and let your journey through the stars begin, an artistic adventure that is truly timeless.